I think now is the time to start our next session. Good morning, everyone. My name is Edita Kudlek, and I have the honor to be the chair of the session entitled Sustainable Management of Raw Materials. We will have 7 presentations. I warmly ask all presenters to keep the time limit and the whole audience to ask questions after each presentation. So let us start with the first presentation, which will be given by Nadia Gruzinska from Łódź. Is Ms. Nadia with us? I think we will skip Ms. Nadia and go to our second presenter, Professor Michel Finel. Yes? So, Professor, the floor is yours.
Okay, thank you for the introduction. My name is, as you said, Michel Finel. I'm from the Swedish University of Agricultural Sciences, the Department of Forest Biomaterials and Technology, up in northern Sweden on the northeast coast of Sweden. And I will tell you a little bit about spectroscopic techniques for determining the sapwood to heartwood ratio in sawdust from spruce and pine. And this is for pellet production. We want to know the ratio of heartwood and sapwood. So a little bit about the pellet industry in Sweden. We have about 60 pellet factories. The production capacity is about 2.6 million ton each year. 2033, we produced about 1.7 million ton pellets. That equals about 8.3 terawatt hours. We also had a small import, 287,000 ton, mainly from the Baltic countries, and also a small export, 192,000 tons, and that's mainly to Denmark. The raw material we use for pellet production, that's mainly sawdust from the sawmills, the byproduct. When sawing out logs and planks from the logs, we get about 10% of sawdust as a byproduct. And the mixture is about 50% pine, 50% spruce. We have some more pine in the northern parts of Sweden and some more spruce in the southern part of Sweden. It's well known since before that the processing and the quality of pellets made from spruce is quite different. We know we have to adjust the process if we are processing pine or if we are processing spruce. But often they use a mixture of pine and spruce, but there are factories that are using just pine or just spruce. Beside that, we also recently published that there is a great difference between the heartwood and sapwood when producing pellets, especially from pine. And you know the heartwood is the inner part of the log with dead cells, and the sapwood is the outer part of the log transporting water. And in combination with different drying processes, there are great differences in the quality of the pellets produced. And some challenges when producing pellets, that's self-heating and the emission of carbon monoxide and methane when producing pellet from fresh pine sawdust. So to avoid this problem, they usually store the sawdust for 3 months or longer. Storing it for a year or longer, it's not uncommon, but it's quite expensive to have a big pile of sawdust just to store it to get this sawdust maturation. But we get a better quality of the pellet and lower the risk of self-heating and emission of gases when store the material. But we also found out in our study that there's a great difference between heartwood and sapwood when we're looking to the self-heating tendency and off-gassing tendency. The problem is that we can't separate heartwood and sapwood at the sawmills. Sometimes it's difficult to separate pine and spruce, but in the best cases we get pine and spruce, but heartwood and sapwood, it's difficult or impossible. But this is a typical pellet factory. It's the Solör Bioenergi Älvdalen factory in mid-Sweden. They're producing 70,000 ton pellets each year, mainly from pine. And you can see they have a big mountain of stored pine sawdust. This pile has been stored for a year or longer. They also have a pile of fresh pine sawdust, and they have a pile of spruce sawdust. And they mix these because in proportions they know that work. 2 parts stored, 1 part fresh sawdust or something like that. But our idea here was to use spectroscopic methods like NIR to determine or assess the proportion of sapwood and heartwood in sawdust for pellet production. And this would be a fast and easy non-destructible method, but we know it needs some calibration, but it could give a fast answer if the raw material is okay or if it's problematic for pellet production. So we prepared some sawdust sample. We cut down a pine tree and a spruce tree. We separated the sapwood and the heartwood. We ground it down to a fine powder. We dried it to the same moisture content. We sieved it to get the same particle size distribution. And then we mixed it to make calibration samples and validation samples, different proportions. And after some PLS multivariate calibration, we could get really nice models for both spruce and pine. And you can see on the x-axis of the figures, we have the observed sapwood content, and on the y-axis and on the x-axis, we have the predicted sapwood content. And you can see there's a straight line, so the models are really, really good. So this leads us to the conclusion that it is possible to use NIR, and most of the pellet factories actually already got NIR equipment for determining of the moisture content, but they could also see the heartwood to sapwood ratio if they want. But the model's really good, R-square 0.97 to 0.99, but we know we need more calibration because these samples we had were prepared in laboratory scale. We need some more industrial scale material for calibration also. But it seems possible to use this method to determine the material if it's good or problematic for pellet production. Okay, my time is out. Thank you.
Thank you very much for your very nice presentation and for keeping the time limits. So now the discussion is open. Please feel free to ask questions. Yes, please.
Thanks, Professor Michael. It was very interesting work, very easy technology to implement as well. My question will be, I know you might have data. Do you think that the time of storage, right, because you prepare the samples in lab, but the time of storage will be variable, as you said, in the actual sample. And will that impact the characterization using IR method?
Probably. We need a much more bigger calibration sample. We need different aging, different particle size, different moisture content. This was just a small, in lab scale, with a student of mine who did the experiment. So.
I'm hoping that. Thank you. Yeah. Thanks. All the best.
So thank you. Maybe a second question? So maybe I can ask a question. What is the most crucial part during the NIR analysis?
Well, it's sensitive for moisture content, for particle size distribution. But if you have a big enough calibration sample, then it's possible to have it like online on a belt conveyor or something. And it seems that it's possible. But the most crucial part, difficult to say, could be many things.
So thank you. Thank you once again for your presentation.
Okay,
So,
thank you.
so is Nadia Gruzinska with us? No. So let us go to the third presentation from German Smetana. Yes, German is with us. So the floor is yours.
Good day. My name is German Smetana. I'm a PhD student on Częstochowa Polytechnic. And today I'm going to present a presentation on the topic, a review on startup strategies and operation for oxygenic photogranule process. And this is the scope of the presentation, and what are the research gaps and objective of literature review. Lack of standardized protocol for initiating the OPG process, particularly regarding cultivation conditions as well as startup and operation parameters. And the second gap, which was covered in my presentation, is no comprehensive synthesis of data related to OPG initiation process. That creates a barrier to a deeper understanding of how startup conditions affect OPG size, morphology, and performance in reactors. And therefore, objective of the presentation: analysis and aggregation of available data on initiation of the process, cultivation, morphology, performance, to provide assistance for future studies on this topic. So, what are the oxygenic photogranules? These are spherical microbial aggregates that are composed of filamentous cyanobacteria in the outer layer and heterotrophic microorganisms in the inner core of a granule. There is a cross-section of this granule. And cyanobacteria are known for production of oxygen. And in this case, oxygen is used by heterotrophic microorganisms to decompose organic matter in wastewater if it is applied for wastewater treatment. And the technology can be potentially alternative to conventional activated sludge process, which is expensive. There are two types of cultivation: hydrostatic cultivation and hydrodynamic cultivation, and reactor operation also. The former is done when activated sludge is inoculated in a scintillation vial for a certain period of time. Light illumination is provided, and three distinct morphologies are obtained: floating sphere, settled sphere, and disc-shaped granule. In case of hydrodynamic cultivation and reactor operation, we have here a typical SBR cycle. It's reaction, settling, decantation, feeding, excess sludge removal to sustain appropriate sludge retention time. And what are the reported values for the parameters for hydrostatic cultivation? Total suspended solids, volatile suspended solids. The range is given here. It's quite large. It means that we can use quite highly loaded activated sludge for this process. Light intensity range is given. Activated sludge to scintillation vial volume ratio, it's mostly 1 to 2, but other ratios are also provided here, were also reported in the researchers. Period of cultivation, it's typically 3-6 weeks. Type of light source, it's mostly fluorescent light bulbs, rarely LED lamps, but more specific information is on exact lamps used, and the researchers is limited. Temperature of cultivation is room temperature. Hydrodynamic cultivation, type of mixing, impellers, gas agitation, magnetic stirrers. Other parameters are also activated sludge used for hydrodynamic cultivation. Primarily effluent and synthetic wastewater are used for reactor operation. And okay, there are continuation of these parameters also, and hydrostatically growing granules look as presented on this slide. These are just spheres, and the table presents here the comparison between hydrostatically grown granules and hydrodynamically grown granules. The former are bigger, and settling velocity is also bigger. And these are how hydrodynamically grown granules look like. There are two distinct morphologies, bold or filamentous granules. And under microscope, we see how they look like, and conclusions and future research directions. Uniformity of equipment specifications and operation parameters is important for the future application of this technology in large scale. The morphology of granules depends on startup and operational conditions, and it in turn affects physical properties of the granules as well as wastewater treatment performance and future research direction. There is a lack of data on application of other components for wastewater which is used in researches other than sodium acetate. The in-depth research on in direction of process control and monitoring is required. The impact of particular microbial communities on startup and operation should be investigated. Also, investigation towards the treatment of emerging contaminants should be done. And it is still unclear how a particular OPG shape, either spherical or bold, spherical, bold, or filamentous forms, what factors lead to it, and how it affects the treatment process. And that is all. Thank you for your attention.
So thank you very much for your very fast presentation. So now I open the discussion. Maybe someone have a question to our presenter. Yes, please.
I was going to ask about the size, but you already showed that the data is not available. But there's another question I was wondering, because the OPGs, right? They have to be cultivated first in a condition,
Yes.
Then they have to add it to the wastewater.
Yes, exactly.
And then exactly, and then based on their size and type, they may either form a mat like on the surface, or they may sink. And but we need to have a proper distribution of OPGs through the wastewater in order to attain their proper functioning. So how will that be achieved? Do you have any information on that?
No, yes, so the granules should be cultivated either in hydrostatic cultivation or either hydrodynamic cultivation. And when they are cultivated, in case of former, there is a shake test. Sensillation vial is just shaken, and whether the form is sustained, it can be used for inoculation. If the form of a granule is not sustained, if it is broken, it often happens, then we cannot use it for inoculation.
Okay.
Yes.
So that's how you determine
how
whether
it
it's
is done.
working or not.
Yes.
Okay. Thank you.
So maybe another question. So you are at the beginning of your research work, yes? Or
No, actually, continuation.
continuation. Okay. So what will be the future of your work? What is the goal, the main goal?
No, I currently work on anaerobic digestion in a upflow anaerobic sludge blanket reactor of dairy and brewery wastewater. And after when the fermentation is done, I want to apply oxygen photogranules technology to see whether these post-treatment, how it is called, wastewater can be treated here with this technology, whether they can actually be applied for treatment.
Okay, so you are searching for the possible application of your,
Yes.
of your solution. So thank you once again very much for your very nice presentation.
Thank you very much.
Thank you. Maybe applause. And we go to the next presenter, which will be Łukasz Wójcicki from the Zarisza University of Technology. So please, the floor is yours.
everyone. In today's presentation, I would like to present my results of my new research based on selective sorption of cobalt in the presence of nickel ions using a chitosan hydrogel grafted with 1,2-pydrolose-2-naphthol. And I'm conducting this research at the Department of Inorganic Chemistry, Analytical Chemistry and Electrochemistry at the Silesian University of Technology in Gliwice under the supervision of Dr. Joanna Kluczka. Currently, I'm a PhD student, so I'm starting my journey in science. However, at the beginning, I carried out, I'm really interested in sorption process. In my first level of degree, I dealing problem for selection of the sorbing agents in the recovery of phosphorus from chitosan hydrogel. At the second step, I moved to the hard one process, so the selective process, and because of that, nowadays I'm dealing a research based on selective sorption, and I wanted to not only synthesize material that have a high affinity or some adsorption capacity or sorption capacity for some inorganic pollution, but I wanted to do as selectively as I can, and I think that's the future for new technology in material science. As we all know, water is really crucial resource, and we have to take care of that. And some of the methods can be used for revitalization of aquatic environment, such as physical method, chemical, biological, and physical-chemical. In physical-chemical method, the physical-chemical method include the sorption technique, and that's why I'm currently dealing with that technique. According to the European Union's reports, we have a huge issue about a critical metal, and right now I'm from all of that metals, I'm dealing with cobalt and nickel ions. And as you can see from the graph, the cobalt has more economic importance and higher supply risk than nickel. And that's why in my research I'm focused not only to remove cobalt from water, but to do selectively to separate the cobalt and nickel ions in one step. So the step will be sorption, selective sorption. And chitosan, like pectin and cellulose, occur naturally in environment. Chitosan occur in the form of chitin, and as you can see on the slide, the structure of the chitosan have some amine group which have some ability to bind metal ions, and that's the advantage of that biopolymer. And the second compound is a PAN, and I used that compound as a filling because this compound create a stable complex with cobalt. So I wanted to mix that kind of properties to make a material that can be used for cobalt ion removal. And the first research was carried out using only chitosan hydrogel to check out if is a problem to remove cobalt and nickel using that kind of hydrogel. And in the first graph, you can see that if we increase the concentration of nickel in cobalt solution, the sorption capacity of cobalt decrease. So that means the nickel ions are competitive ions for cobalt sorption. On the second graph, you can see that chitose and hydrogel have more ability to bind nickel rather than cobalt, so it's a huge problem. And I wanted to make the modification of chitosan in that way to increase the cobalt sorption rather than nickel. Next research was carried out using a modification of that kind of chitosan hydrogel grafted with PAN. I used a few of cross-linking agents such as epichlorohydrin, glutyraldehyde, and tripolyphosphate. And as you can see on the graph, higher selectivity was conducted using sorbent cross-linked with epichlorohydrin. That's why the next research I'm interested in that kind of sorbent. I also carried out a research to check out if how form of chitosan influence on selectivity and sorption of cobalt and nickel, and you can see some synergistic effect. And the best of the result is for hydrogel of sorbent with grafted and in the PAN filling, with the PAN filling. Next research conducted to check influence of PAN content in the sorbent, and you can see that if we are increasing the PAN sorbent, PAN filling in the sorbent, we increase the selectivity of cobalt removal rather next to nickel ions. And if we cross-link that kind of sorbents in epichlorohydrin, we can see a little bit decreased in sorption capacity, but we increased the selectivity of the process. Finally, I'm carried out a research using an ion imprinting technology, and you can see that that the best result was for the cobalt, was for the sorbent ion imprinted with cobalt, and the that kind of sorbent have some ability to sorb lots of cobalt ions rather than nickel. And the final slide, I wanted to present you my procedure of synthesis, and in the future research I would like to determine mass balance of that kind of synthesis, and also carried out a lot of sorption characteristics of that kind of sorbents. And thank you for your attention. I'm happy to answer any question you may have.
So thank you. And we open the discussion. Yes, please.
It's very interesting, a lot of results you have shown, but I cannot dissect into all of them, but at least one thing I would like to know, that what enables, when you add PAN, what enables the selectivity between cobalt and nickel? So that's very interesting to know. I mean, can you please throw some light on what makes it?
Yeah, currently I didn't, I only conduct the research for characteristic sorption, and the next step I wanted to make some proposal of mechanism of that kind of sorbent and sorption technique. I have some analysis to do, like IR or XPS, SEM, EDS, and so on. So I'm only beginning for, to get information about the mechanism of that kind of process.
That's interesting. I'll be waiting for that.
Thank you.
So maybe another question? Someone else want to ask our presenter? No? So I wish you very good luck with your future research. You have a lot of work to do in the future to check the stability of your sorbent, and a lot of work to do. So congratulations that you already start your research, and good luck for the future.
Thank you.
Thank you once again. And our next presenter will be Professor Alexander Lukasz. Is he with us? Yes, so Professor.
Dear colleagues, let me introduce the presentation possibilities of the rare source using of Robinia genus species in the Chernihiv city's green infrastructure Ukraine in content with their different invasive activity. There are Chernihiv city is situated in the north of Ukraine, in the forest zone, near the border with Russia and Belarus. There are two introduced plant species of Robinia genus with the North American native ranger, are in green infrastructure of Chernihiv city. They are Robinia viscosa or clammy locust and Robinia pseudoacacia black locust. What are the difference in the invasive activity of Robinia pseudoacacia and Robinia viscosa? Robinia pseudoacacia has naturalized in the native plant communities and already posing a danger to biological diversity of the Chernihiv city in green infrastructure. Robinia viscosa not widely used in the green construction of Chernihiv city, but this species has long been planted in many European countries as an ornamental plant and used to restore degraded areas and urban trees. Robinia viscosa is non-invasive species in green infrastructure of Chernihiv city because the artificial territorial isolation from natural plant communities. The second is it has very long generative potential in condition of introduction of the Chernihiv city green infrastructure. But potential of vegetative propagation by root sprouts is very high. On pictures, you can see that in urban territories, phytocynosis, 1, 5, 7 years old plant produces from 9 to 16 root sprouts per growing season at a distance from 1 to 8 meters from the mother plants. How can we use the Robinia pseudoacacia? First of all, it's a wonderful medicinal plant because it has antibacterial, antioxidant, anticancer properties. The secondary. It's honey-making trees. Honey productivity up to 1,000 kilograms from 1 hectare. And the third is the more important for title of our conference, Robinia pseudoacacia as an invasive, as an aggressive species in green infrastructure can be used as a dendromass material. As you know, Ukraine have very problems with the energetics. Now I situate in Poland, and tomorrow I will come to Ukraine, and in my house is absent electric, will be. Because only 8 hours can be electric power in buildings of Ukraine now. I want that you see this table. On this table, you can see the results of comparison of the firewood from tree species with wood of high hardness. These species are Quercus robur, common oak, Fraxinus excelsior, and also Robinia pseudoacacia. As you see, the calorific value of Robinia pseudoacacia is the same as Quercus robur, common oak. How we can use the Robinia viscosa. Robinia viscosa. As you know, it's not so invasive active species. So it can be used in landscaping of green infrastructure of Chernihiv city. Second, it's wonderful melliferous species. Its honey productivity is higher than Robinia pseudoacacia. It is honey productivity is more than 1,000 kilograms from 1 hectare. And the third aspect is very important. I want to note that the Polish researcher Konarska, which studies Robinia viscosa, there are very little scientific works in which study Robinia viscosa. But Polish researcher Konarska in 2020 knows that Robinia viscosa is valuable melliferous species. She studied the anatomy and physiology peculiarities of this species. And the third aspect, Robinia viscosa, I think, is the prominent medical plant, because if you can, how you can see the list of substantia in this in flowers and foliars of these species can be perspective antibacterial and antioxidant raw materials. Thank you for your attention. You can see the results. In conclusion, that is it. Thank you very much.
So thank you for your nice presentation. You are showing us a lot of use for invasive plants. So we have, first of all, search for the uses of them and not completely destroy them.
The most people, scientists, botanists, knows that Robinia pseudoacacia is aggressive invasive species. But deleted this species, we cannot. This species grows and will be grow. Because we must see the ways of the using invasive species as a raw materials, and I present the results of our research with my doctorand and with the Polish colleges from Pomeranian University in Słupsk.
So thank you. Maybe someone have a question?
Thank you.
So if not, once again, thank you that
Thank
you
you
are
very
with
much.
us. We are very happy.
Jeszcze poproszę, bardzo chciałbym podziękować wszystkim organizatorom konferencji naukowej za pięknie organizację konferencji, za wspaniałe spotkanie. Dziękuję bardzo organizatorom.
So, our next presentation will be given by Agnieszka Przybek. So please, Agnieszka, the floor is yours.
Okay. Good morning, everyone. My name is Agnieszka Przybek. I am a third year PhD student at Krakow University of Technology, and the theme of my presentation was investigation of qualities of layered geopolymer composite based on aluminosilicate and fibers of natural origin. The introduction of increasingly stringent heat transfer coefficient requirements for building material and the drive for widespread adoption of passive construction are forcing the development of advanced building material with thermal insulation properties, and the use of post-mining waste is in line with the principle of zero waste Europe, resources efficient Europe, and the circular economy. The benefit of the developing modern materials based on geopolymers and natural fibers is also that such materials implemented on an industrial scale can be produced at a much lower cost. And in addition, due to the possibility of using waste and fibers, which are renewable material, do not contribute to excessive use of natural resources. My work will present the results of physical, mechanical, and thermal properties of my layered geopolymer composite with addition of natural plant fibers. For this study, I selected a kind of natural materials with, in the form of mats, wool, and felt. I chose linen wool, flax jute wool, hemp wool, coconut mat, jute felt, flax jute felt, flax hemp felt, linen felt, and hemp felt. For this material, I test the density and the thermal conductivity. The thermal conductivity tests were carried out in at 0 to 20 degrees Celsius. Based on my result, I choose two similar products with similar properties. And I choose flax hemp felt and coconut mat to my layered geopolymer composite. For the geopolymer composite, I selected two base material. The first is fly ash, and the second is sand. Fly ash is characterized by diglinium silicon dioxide in chemical composition and diglinium trioxide. Sand, on the other hand, contains mainly silica and traces of iron, calcium, potassium, and sulfur oxides. I also test mineral fuzz tests carried out for my base material. For fly ash, I identified fuzz such as quartz, mullite, hematite, magnetite, anhydrite, and rutile. For sand, however, I identified only quartz and calcite fuzz. Particle size analysis for sand and fly ash showed that average particle size for fly ash is around of 13 micrometers. On the other hand, sand has average particle size of 200 micrometers. This material has specific fly ash has specific area 10 times higher than sand. Both materials are mesopores, and fly ash has a small pore size. To make geopolymer composite monolithic and not delaminate my product, I use a composite bar who has better properties to steel and is more cheaper, has a low price and lightweight. The slides show how the layered is placed in my composite. The first picture is composite, the next is insulation material, and the third is core material geopolymer. Adding the natural insulation to my composite reduce the density up to 40%. And the second, the addition of natural insulation in geopolymer composites are resulted in a decrease in thermal properties up to 60%. The bars in the strength test, where strength test specimens are placed in two ways. One single bar along the whole sample, and three short bars were placed. The natural insulation resulted in a flexural strength, but decrease in flexural strength, and this result is similar to lightweight concrete. And similar conclusion were obtained to compressive strength test. The natural insulation resulted in a decrease in a compressive strength, and this is a similar result for lightweight concretes. And the finished material can find used in construction, building partition, and last but not least, prefabricated. The solution presented is ecological because I used waste material and natural fibers. And natural fibers are renewable, and fly ash is byproduct of coal burning. And thank you very much for your attention.
So thank you for your nice presentation. I open the discussion. So have someone a question? So you already have a cooperation with the industry to invite your
Yes,
product to the industry?
Yes, I show my product with industry and we test our product in company Wengpsham with your equipment.
With their equipment?
Equipment, yes.
And they are
yes.
interested to go
Yes.
further with the research and
Yes.
implement it in the future.
Yes.
So congratulations
Thank
once
you.
again.
Thank you very
So,
much.
Thank you. So our last presentation for today will be given by Haider Hakoum. Have this presenter with us. Okay, so maybe I will go back to Nadia Gruzinska. Is he now present? She now present? Also no. So I warmly thank you for your presence at this session. It was a great pleasure to host the session with such a great audience. I thank you once again to all presenters. I wish you good luck with your future research, and thank you once again for today.
Doesn't work. Oh, now it's working. I will say a few words. Thank you very much for the excellent moderating this session to Professor Edyta Kudlek. Yeah, thank you. So now at 12 we have the lunch break again. So you are very welcome to go downstairs to a restaurant to the lunch break. And then at 1 we start again with the session dedicated to the energy. And please stay with us to the last session because we also will announce the winners of each session, including the poster session with small awards for the best presenters. Thank you very much, and you can join the lunch now.
Good afternoon. My name is Piotr Olczak. I'm representing Mineral and Energy Economy Research Institute. It's a part of Polish Academy of Science. I will be very happy to be a chair of the session Sustainable Management of Energy Resource. The time for each presentation is 7 minutes, and after each presentation will be discussion. It's my pleasure to invite the first presenter, first speaker of this session, Mr. Pradeep from AGS University of Kraków.
Thank you. Good afternoon, everyone, and thanks, Chair, for the introduction. I'm Pradeep from AGS University of Krakow, and I'm here to present my work on recycling end-of-life crystalline silicon photovoltaic panels. And I'm standing here because of my grants, Polonaise-based and European Union Marie Skłodowska-Curie action, which enabled me to come here and carry out my research in AGH Krakow, in lovely city of Krakow. The work that I'm going to present today is in multiple phases. So part of this work was done when I was in Singapore with another grant. I had my group in Singapore as well, but then I came here and I further expanded that research. So I will be showing results of both places. Let's begin. So we know that establishment of photovoltaic panels is a positive response to combat climate change and to give green energy. But with that, with more installations also comes more waste. And it has been estimated that by 2050, we may have anywhere between 60 to 70 million tons of photovoltaic panels lying unused or lying rejected. What to do with them? Nobody knows. And this scared European Union first. And then they set up a panel to discuss what could be done with this. And this was the result of a report which they published that if managed properly, this can generate income streams of up to maybe 20-30 millions of euros. This can be generated using in 2030, as far as 30, and then in 2050 it can go up to even 15 billion of material cycle. Now, before this, why recycling of photovoltaic panels is so difficult? Because making them is also very difficult. We put our whole efforts to make sure that photovoltaic panels are IP68 rated, same as your phone almost, which means there's no water ingress, there's no moisture ingress, and we make sure that these layers are perfectly sealed. And as you see, there are complicated layers here. There's glass, there is metal, there is polymers, there is silicon solar cell, which is the heart of the shoe, and this is the main thing I'll come to later. And in silicon solar cells are not single thing. They have silicon, they have metals, silver, aluminum, they have different layers as well. And this makes recycling of photovoltaic panels extremely complicated process. And hence, a lot of research is required in this direction. Now, this is one of my favorite charts. This I presented first time 2 years ago in EU-PV-SEC in Lisbon, and I showed that although European Union said that we have to recycle 90% by weight, people were skirting that by 90% of weight only includes glass and maybe some aluminum. The main value which is there, which is in silicon, and this 0.1% is silver, that accounts for 90% of the value that is going to waste. So what were companies doing? Usually, there are 4 steps in a recycling of photovoltaic panels. It starts with disassembly, delamination, sorting, and extraction. And out of these 2, delamination and extraction are 2 most difficult steps. Obviously, delamination, because, as I mentioned, we have put a lot of effort to make sure they don't come apart. So picking them apart is not an easy process. And this is few industries we visited, and what they did, they just used to recycle, in the name of recycling, they just used to remove these cables, metal part, the glass, aluminum, and this is just throw away in landfills. And this is the photo what I showed earlier. This was their recycling. Because they covered 90% of the weight, but by value it was less than 20%. And the main value was being thrown away. So my first research was how to make photovoltaics 100% recyclable. And the first thing is, so as I mentioned, so when I found out that the most critical process is delamination, I first focused my attention towards developing process for delamination. So usually, you can find some process for delamination. There is chemical, thermal. Sometimes few researchers who propose this, during chemical delamination, they immerse the photovoltaic panels in chemicals, and they take 96 days to come apart, immersed in chemical. So then, with my grant, when I was earlier in Singapore, we developed a new process known as electrohydraulic fragmentation, with which we were using water and a pulse jet to completely fragment. I won't go into details of that, but I'll just show you quickly what I did. And then we have a sorting of these different ways. But then with my process, or with the process that we developed, we included sorting in the process itself. And it looks something like this. So when you recycle solar cells, we have a lot of materials to recover. We have silver, aluminum, copper, and all this. And this can be only recovered by acid. There is currently no other methods to recover them. So this is the HF process, and then this is what it looked like. So what we did, we took solar cells, we crushed them, we feed them into a chamber. This is our machine, which we designed, self-built. And then we put a charge, an electric arc into it. The water delaminates, the water pressure moves, water is incompressible fluid. So the energy loss here is less than 1%, because it's electrical energy into water fluid, water pressure wave. There's no loss here. And then we take this material, and then we sieve it manually. Now it is an automatic process, and then we get this. So we remove glass, polymers, again glass pieces, and this is silicon and metal powder. Just by manual sieving, we can remove or separate all of them, segregate them. Then we further do etching, and we take these silicon pieces, and then this work was done partially in Singapore, and when I came here, I continued that work here. So we melted this silicon, and we tried to figure out what is the chemical process required to remove metal completely from silicon and completely take silicon out and metal out, but don't throw the metal away. So it was a sequential process to first remove silver, then aluminum, then the other contaminants, and then get pure silicon to put it back into solar cell. And all those can be recovered. So we collaborate in Singapore, we collaborate with industry, and an industry built a solution. So this is our recycling line, pilot line, which is now currently being tested in my previous NUS in Singapore, and we have these machines where we can recover the metal and chemical. But that's only one part. Second part is, a lot of panels have already been wasted, thrown. This works only for those panels which have been collected at the source. The panels which have been thrown, they are so dirty lying over the years that can't be used for closed-loop recycling. So there is open-loop recycling as well. And this is currently the part of my project where we develop ways to make ferrosilicon using that silicon panel recycle. And it is the second most valuable material that can be made using that silicon. And we melt that silicon because you see ferrosilicon can be only made by using carbonaceous reduction. There's a lot of carbon required, a lot of CO2 produced. So if we use this silicon, we don't need carbon at all. So we just need electric furnace, no heat required, the electric furnace, and we can make ferrosilicon. We already made ferrosilicon here in lab, and we already have submitted. Very soon the publication should be out. So in summary, I would like to say that we have to think about methods, not only one. Okay, it's good to have a closed loop cycling, but it is expensive, it takes long time, and currently we are not ready for it. And open loop recycling makes most commercial sense now. So at least we can have different options. So now we can focus, we can use these old panels which have been discarded for open loop recycling, and then slowly, when the supply chain is established, we can go for closed loop recycling as well. I would like to thank my team here, which has helped me a lot. This is my entire team here in AGH. We work together, and all the results were thanks to, I have a student as well, an undergraduate student who helps in this work. And so thanks a lot for your attention. I'm open for questions.
Thank you very much. Thank you, Pradeep, for very interesting presentation, because especially for Poland, because in Poland there are many new photovoltaic installations, but we should do some research about what we will do after 10 or 20 years.
Exactly.
I open the discussion. Any question for Pradeep?
Yes, please.
So what is the average lifespan of such a PV cells, and is there any way not to like reduce only trash, but maybe to change something in, I don't know, like electronics to use them or prolong the usage of photovoltaics for another
Yeah.
years?
I will. It's a very long answer, but I'll try to make it short. We were doing some research when we started this work in Singapore. We were saying that there were 3 ways to do this, and this is my topic of my talk, which I gave in Lisbon: reuse, reduce, recycle. So first step is reuse. So first step we try to do is reuse or prolong the life of photovoltaic panels. Now each photovoltaic panels can last up to 40 years, and they still work. 40. Suggestion, and it still works because even the first photovoltaic panel, which was made in 1958, is still working in US. The first photovoltaic panel which was made is still working. Efficiency is not so great, but it works. So what happens? Why do we have so much waste? Because technology. So what happens is, let's say 15 years ago, we had a photovoltaic panel which was giving 15% efficiency. Over the years, now efficiency is 23%. So what do companies do? They remove those all panels and they install new panels because of the marginal increase in cost of installation is much less than the marginal increase in the profit gain from the electricity sold, because electricity prices have increased. So they throw away these panels, and we have these waste which are quite good panels. So out of these panels, some panels can be, the idea was, and people were doing this, they were taking good panels, like slightly damaged panels, they would repair it and sending to Africa. The concept was African countries would pay for the shipping of the panels, and we give them panels for free, so we reduce our waste and they get money. But then it found out that the cost of shipping of these panels is 3 times the cost of the panels themselves. And panels are not only the part, you have to have grid, you have to have energy storage, you have to have the electronics with it, which are much more expensive than the panels itself. So the entire cycle is not sustainable. That was dumped. And that's why they ended up in dump yard. And that's what's happening. So all the factories, the photos show that's from Africa. So it's plant in Africa.
It's a pity.
That's what happens, right? So photovoltaics already have the largest or longest surviving lifetime for any commercial product available as of now. But we end up waste because, I would say, profitability of industries, which is the most surviving thing. And that's how it is. But there are certain ways to handle that. But I will stop it here because there's time as well.
Thank you very much. The next presenter will be Bartosz Sobik from SGH, Warsaw School of Economics.
So, good afternoon. My name is Bartosz Sobik. I'm a PhD candidate at SGH, Warsaw School of Economics, and the topic of my research is energy transition in Poland from both technical and economical point of view. I would like to draw attention to this issue because we are talking much about technical issues and economical, but we are not talking much about both techno-economical issues. And so as to understand the transition, we need to approach from these 2 sides. So first of all, as most of you know, we have not enough diversity in the Polish energy system. Current electricity mix is dominated by the hard coal and lignite, and we have just a few percent regarding the wind and photovoltaics, which, however, is still growing very rapidly. We have in Poland a problem called investment gap because most of our power units fueled by the coal, mainly hard coal, were built in the 70s and 80s. Therefore, the medium age of coal-fired unit in the Polish system is about 40 years. So we have to replace the oldest units also because the problem of efficiency and emissions of the CO2. And this investment gap could provide a risk of missing capacity, particularly in the end of 20s and the beginning of the 30s, because we are going to phase out coal units and there is not enough power in the system. So particularly, we have to be concentrated as a country to invest in new capacities in the next years. Particularly, we have to finish and speed up our investment in the gas units so as to keep the power generation in the proper way. Also, we need to keep the coal units as long as possible just because of the energy security issues. Because if we will switch off the coal units too early, it will be a missing capacity risk for the whole sector. Nevertheless, we have the problem with the climate risk in Poland particularly, because our energy sector is extremely exposed to the climate risk, and we have to speed up our decarbonization plans, particularly in trying to move towards the photovoltaics, wind, offshore, and probably nuclear. But regarding the nuclear, I will tell you a bit more about the financing problems. And regarding the climate risk, we have two major risks. It's transition risks and physical risks. And regarding the transition, it will be most the transition risk, particularly for the energy companies. In my PhD, I prepared a short-run marginal cost model because we have a electricity market designed based on the merit order principle, and units are allocated according to their SRMC cost, short-run marginal cost. So I've calculated this cost for the Polish units, and we can see that for the hard coal, majority of the cost is the EU ETS CO2 carbon price. But from the other side, for natural gas, for the years during the energy crisis, 2021 and 2022, majority of the costs, well, the fuel cost. So there is a significant market risk in terms of the price of gas. That's the graph which presents the short-term marginal cost in the 2021, and we can see that at the very beginning of the energy crisis in Europe, gas was still the most expensive units in the whole system. 1 year later, during the center of the crisis, gas was a price setter, and the electricity price has been set at this level, so other companies received a huge amounts and a huge earnings, and the market was a bit destroyed by this rule of merit order. And that's why we had an energy crisis in Europe. Make a short summary regarding the short-run marginal cost. We can see that a market was not very efficient in that way, that rising gas prices made electricity prices explode in the whole European Union. Also, I just prepared a quick model in my PhD regarding the scenario analysis of the Polish energy transition from the financial perspectives, because I'm doing my PhD in finance and economics. And I've created 4 scenarios regarding the Polish energy transition. There is scenario 0 without transition, so it's just a benchmark. Let's imagine what would be if Poland will completely resign from the energy transition. Scenario 1 is based on the current energy policy until 2030. Scenario number 2 is balanced between the rapid development of the renewables and the backup with the fossil fuels. And the third is rapid development of renewables. And we can see the results. Also, I've added the 4th regarding renewables with nuclear, number 3, and renewables without nuclear. What's interesting, just from the cost-wise approach, CapEx and OpEx costs, and also financial costs, the cheapest one scenario in terms of investing in the new power sources and the operational costs were scenario with renewables without nuclear. It was definitely cheaper than building at least one nuclear power plant, just from the financial perspectives, because the investment costs, the capex of the nuclear is so huge, and also we will have a huge financing cost regarding the debt financing in, let's say, about 70–75%, and the financing costs could be bigger than the capex. So from this perspective, we can also see that scenario 0, no transition, is definitely the most expensive one scenario. So there is absolutely no choice in transition. We have to do this transition, not only from the technical perspectives, so as to keep the energy security, but also from the perspectives of the market and the prices. Scenario 0 without transition and scenario number 2 delayed transition are on the red color, because there is no possibility to meet energy security criteria from the 2050, and there is no possibility to keep zero emissivity in the Polish power sector from 2050 onwards. Scenario number 1, basing on the current energy policy, still informed that in the 2050 there is a risk of energy security, providing that we will be forced to switch off all emissive units. So if we are going to decarbonize the Polish sector permanently, we have to speed up investment in the renewables. Nevertheless, we have to keep in mind that we need backup, particularly for Dunkelflaute. 2 weeks ago, we had a great example of Dunkelflaute. It was a moment when there were not enough sun and wind, and therefore we was forced to provide more electricity, particularly from the coal. And as the sensitivity analysis regarding the results, these results are not sensitive in the cost aspects. The biggest exposure to the sensitivity is regarding the discount rate. So the discount rate in the model was just 5%. And let's summarize. We need transition. We have to do this transition, but we have to do it wise from the technical point of view, from the energy security issues, and also from the cost-wise issues, because we need to invest, but we have to keep in mind that we shouldn't overinvest. Thank you very much.
Thank you very much for the interesting presentation about the cost of energy transition in Poland. Anyone have any question? Please.
So I have the questions. So the first question is, what is the end year of the transition in your model? And second is, what is the portfolio of the final transition? So if there is still an lignite and black coal, like hard coal, or are there any?
Thank you for the questions. First of all, there is a model from 2023 till 2050, and data for 2023 is the real data. And 2050 is the last year of the model, of the scenario. And the second question, I modeled in this model technologies like hard coal, lignite, natural gas, nuclear units, photovoltaics, wind, offshore, onshore, pumped storage. I excluded hydrogen and SMRs because there is no such technical industrial experiences of examples of such technologies nowadays. So it's kind of very pessimistic approach.
But it's like zero emission or net zero, or it's completely no emissions, or how you...
The aim was completely exclude emissions units. So in 2050, in the scenario, in all scenarios, I made a simulation how the system will work without any gas units and without any hard coal and lignite units.
All right.
So I, of course, implemented a lot of energy storage. So
Thank
just
you.
to keep the balance in the system. Thank you very much.
Thanks a lot. I love the statement that investment in gas is not the response for this section. That's fantastic. My question would be, how did you calculate the CO2 emission, the first column in your table? I would like to know about how did you calculate, because when you talk about only renewables without nuclear, I would like to see how that number came up. Because over a lifetime, renewables are considered to be either net zero or net positive instead of negative. So I would like to know about that.
Thank you very much for a great question. I used the data for emissivity of a given technology. So every single technology has a medium average emissivity per 1 megawatt hour. And regarding the scenario with the renewables, it was very interesting. I didn't have time to explain more. But a scenario with renewables without nuclear received higher CO2 emissions because of balancing using natural gas. In the 40s, we've been forced to use natural gas was to balance the system because we won't have nuclear. So that's why, but the model made the assumption that from 2050 onwards, we don't have any gas. So balancing only using the energy storage and the pumped storage power plants.
So that number is only until 2050?
Yeah,
okay.
Only until 2050.
Okay.
Yeah.
Thank you. That clarifies. Thank you.
Perfect. Thank you very much.
Okay, thank you very much. The next presenter will be Girts Karnitis from University of Latvia. The floor is yours.
Okay. Good afternoon. Nice to see you here. It's almost a miracle to see you all here. It's last day of conference, Friday afternoon after lunch. So, why you are here? Maybe I'm a brilliant presenter. Okay. And yesterday we in one session had this discussion about feasibility of scientific results. So that results from scientific point of view is very nice and promising, but they are so too expensive to use them in business. And business refuse to use them because it's too expensive. And so my topic will be about this feasibility, this economic feasibility, but not in such scientific result, but on urban heating. When you want to make reconstruction of building, there are a number of different possibilities, scenarios, what to do, which one will be the most effective, what will be the costs, and so on. Why it's important? Because we all know those Green Deal and the reduction of greenhouse emissions by 55% by 2030. It's fit for 55. And it would, to achieve this goal, we should reduce heat energy consumption by 60 to 70%. It means you should renovate not only single buildings, but complete city blocks or even some city completely. And actually there is minimal EU and national funding for that. It means that those owners of those buildings, private owners, and so on, should invest their money, and there should be something to give them, I don't know, something so that they are willing to invest their money in this. So, and we have created a tool, actually, because there was this request that you need some tool that provides flexible and quick and at the same time sufficiently accurate analysis of potential those reconstruction variants. And you can use this in pre-design stage. Is it feasible to make such reconstruction even, or maybe we just skip this and that's all. Also, this tool allows different scale from single building, for example, one family single building up to city, whole city, for example, with a lot of buildings. Also, there is analysis of different variants determining project or single building variant optimum and whole together, whole project overall optimum. Also, we created that tool so that we need minimum data. We use heating certificates which are made by standard which are all around the European standard for heating certificates, and we use only data in those certificates. And it's very simple to use, no specific knowledge needed, because most tools are so that you should be specialist in thermophysics or economics or things like that, but this tool can be used by anyone. This tool gives you a number of different numbers, let's say this way. So we can get out a lot of things, and you, for example, here you put in, for example, existing information about existing wall, how it's built, how thick, what is internal temperature of building. Residential house has one, some warehouse has different temperature internal, and then how would you like to insulate, how thick, and you get results, what will be different, what gains you cost, how effective it will be, and so on. And here is one example. You have, for example, some house with local heating system, local gas boiler. One option, insulate building. Second option, change boiler to pellet boiler. And third option, put together this first and second one, and this will be the most, you gain the most, but it will be actually the most expensive one. And actually option 2, as you see, if you change to pellet boiler, these CO2 emissions, yes, there will be lower, but still there will be a lot. But this will be green energy because you don't use fossil gas, natural gas. And we compare we took 3 houses, different size, and make more than 50 different variants of reconstruction, different wall insulating, different basement insulating, different this roof insulation, changing of windows and so on, make different combinations, more than 50, and compare it to one professionally used tool, which is very complex to use actually. As you see, this difference in results were very small. All of results were less than 10% difference, and in 75% cases it was less than 5% difference of results. of this error margin. So, and yes, this is who's authors. We are from University of Latvia, and yes, thank you everyone, and yes, any questions?
Thank you what you said. We are waiting for the question for the audience. Please.
I would be interested in the way, because thermal insulation, I mean the building insulation, there are a lot of research which shows that not only improves the energy quality, it also improves something known as EPI, which is Energy Performance Index of certain buildings. I hope you've certainly taken into account. And then, so that has an additional cost, positive cost in terms of CO2 enhancement, because improving the energy index also reduces a lot of other emissions. So was that taken into account for this model?
No, we are not. Actually, we skipped this part, how much CO2 it costs to produce, yes.
Okay, thank you. That's my question. Thanks a lot.
Thank you. We had time only for one question. Thank you very much, Professor.
Thank you.
The next presenter will be Grzegorz Cema from Silesian University of Technology.
Good afternoon. I represent Silesian University of Technology, and I will present the results of our research concerning the biomethanation process. The research we made within the project Waste Value, which is related to the recovery of resources from organic fraction of municipal waste solids. And the project was divided into 5 work packages. However, our goal, our objective in our team was related to creating of the optimized system for producing enriched biogas through anaerobic digestion. And when we are looking to the biogas production and energy production in Europe, for now, and especially in Poland, we are using coal energy and from gas. But looking to the European Union politics, especially in the climate change and reduction of the carbon dioxide emission, we have to look to reduce also using the natural gas as a fossil fuel, which was done, for example, in Copenhagen. And when we look for the potential of the production of the biogas in Europe, there is the huge potential in Europe, also in Poland. And the goal of our research was to use the hydrogen to produce biomethane, because when we want to remove the natural gas and replace it with the biogas, we have to think, and we want to introduce to the gas system, we have to think about the impurities in the biogas, especially taking into account carbon dioxide production. When we look to the biogas, the methane content is something like 60–70%. The rest, mainly there is the carbon dioxide, and we have to remove it or transform, because we have a good developed technology to remove the carbon dioxide from the biogas. Okay, we can consider it as a product also, but in our point of view, it's a waste. We want to use this carbon dioxide, transform it into the methane. So we want to use the hydrogen connected with the carbon dioxide to produce more methane. And to change this biogas content with the methane, something like 60–70% maybe, into 85% or even over 90%. And for this project, we use 2 different technologies. In situ, biomethanation, so we introduced the hydrogen gas into anaerobic digestion reactor. There was one step where anaerobic digestion and biomethanation took place in the one reactor. We use CSTR reactors for that. And then we change into ex situ process. So we have 2 steps. At first, there was just anaerobic digestion of the biomass. And in the second step, we introduced the hydrogen to the anaerobic digestion reactor, and there was the biomethanation process. With the biomethanation process and in hydrogen injection into the bioreactors, what is the most important is the availability of the hydrogen for the microorganism. the solubility of the hydrogen is very low, especially when you compare with the carbon dioxide. The solubility and viability of the hydrogen of the microorganisms is really, really very, very low. So the most important is to how to introduce this hydrogen into the reactor, how to disperse it in the reactor and make it available for the microorganisms. So the first step was to choose the proper injection to the, of hydrogen to the reactor, and then how to disperse it in the reactor. So we used special designed ceramic diffuser with the pore size equal to 0.5 micron. And we ordered such diffuser and tested in our reactor. At first, we have to check the proper ratio of the hydrogen to the carbon dioxide, and it was, according to the literature, the best results were for 4:1. That was us with the literature, and it was with the mesophilic condition. It was correct. When we increased the ratio above 4:1, there was less production of the methane. So we started our test. At first, just introduction of the hydrogen to the reactor, and okay, we observed the increase of the methane content from 54.5 to almost 70%, but it was still too low. Okay, the baseline was quite low. What was the baseline for the control reactors is only 55%, but anyway, there was still in the off-gas was still a lot of carbon dioxide and also the hydrogen, so it means the hydrogen was escaping for us from the reactor. So we introduced the recirculation of the biogas because there are two options. We can increase the speed of the mixing in the reactor, but in the real condition, at the full scale, it will cost a lot of money for the energy consumption and other technological problems with the mixing. So we decided to use the recirculation of the biogas, and it started work. We increased from almost 70 to almost 80%, but still we can observe that there are some carbon dioxide and hydrogen going out from the reactor. So we changed the condition to the thermophilic from 37 to 55 centigrade degree. And during that, we start to observe some problems, but it was more technical problems with the gas leaking and creation of the big bubbles of the hydrogen in the reactor, in the diffuser, close to the nipple. So we ordered a new diffuser in the company, so that was good that there was the quite small company, we can discuss with them, so they designed a special diffuser for us, and we changed it and it started work. So finally, the gas content, the methane content in the reactor increased to 85, almost 85%. But for that reactor, there was the limit for us, and then we changed into the ex situ biomethanation. And okay, the methane content in this reactor was a little bit lower. It was almost 80%, but in the same time, the yield of the methane production was almost twice, like in situ reactor. However, in this type of ex situ system, we have the also technical problem because we use the other type of the reactor. In the in situ, what was a CSTR reactor, in ex situ, it was column type of the reactor, and we observed a big problem with the mixing and with the clogging of the diffuser. So anyway, we know the problem, so we can solve it in the later research. But anyway, the use of the hydrogen to produce the biomethane is a kind of good solution. We can obtain quite high methane content in the biogas, and using the biomethane is a good also for the stabilization of the system. When we look to the renewable energy systems, for the sun or wind energy, very unstable systems. We observed it in the November that there was no wind, no sun, so the energy production was mainly from the coal systems. But with the biogas, we can easily store it, so it's the kind of stable energy system. Thank you very much.
Thank you. It is time for one question. maybe my question, how do you think how will be important biogas in energy transition in Poland?
I think it will be quite important. It was a presentation before that we have energy transformation and we need some stabilization of our system. If we remove from our system the natural gas, the coal energy, and we transform into wind and solar energy, it will be unstable. Okay, we can produce some nuclear energy, but also when you use the biogas system, biogas plant, and especially with the production of biomethane, it will be the energy source will be maybe 10, maybe 20%, but it will be some kind of stabilization of the system. So in this way, it's very important.
Thank you very much.
Thank you.
The next, maybe during the break, the next question, because we are out of time. The next presenter will be Maria del Mar Sertillo Gonzalez.
Okay. Hello, everyone. My name is Maria Cerrillo González, and I am a postdoctoral researcher at the University of Malaga. And today I'm going to present some of the results of our last study entitled Enhancing Metal Recovery from Lithium-ion Battery Cathodes, Optimization of Leaching and Reactor Configuration. So it's nothing new if I say that the lithium-ion batteries play an important role in our society, and of course we need to recycle these kind of batteries because it became a problem in the future. So today the lithium-ion batteries recycling process are based on the metallurgical processes, and basically it consists in the batteries submit to different pretreatment steps. First, thermal and physical pretreatment to separate the component and to facilitate the dissolution of the metal in the leaching step via acid leaching. And then once the metals are in the solution, they are separated by different techniques like precipitation, solvent extraction, and electrochemical methods. And also all these methods are, all these steps are important in the process. The leaching is the limiting factor of the whole processes. And in this step, the use of acid and reducing agents are required to dissolve the metal containing the batteries and become these metals, soluble metals. And okay, this the leaching step has some drawbacks because it necessary a lot of reagents and also a lot of water. And of course, the subsequent another problem is this generation of a lot of waste and wastewater. But if we look deeply the reaction, also there are a lot of there are other problems, and one of them is the phenomenon that takes place in the leaching, and it's basically consists in the generation of a crust around the unreacted core, and this insoluble crust hinder the reaction. So the reaction stops due to the limitation of the proton diffusion from the solution to the unreacted core. So in one of our previous study, we describe different reaction mechanisms, and one of them are basically these two are defined with these two reactions. The first one is only the dissolution of the particle with an acid, and the second one, the dissolution in the presence of a reducing agent. In the first one, the problem is this crust appear, while in the second one, this crust is not appear because the reducing agents enhance the dissolution. But in terms of efficiency, it will be ideal if only the reaction 2 take place, but it's not possible. It's not possible because both reactions takes place at the same time. But we can modify the condition in the reaction to promote the selectivity of the reaction 2. So if we define the selectivity as the ratio between the desired reaction rate between the undesired reaction rate we obtain this expression, and the selectivity will be maximized when the concentration of the hydrogen peroxide is high and the concentration of the proton is low. But this condition is not possible to take place in a batch reactor, that is the typical reactor using the leaching process, because in this kind of reactor, both the solid and the solution with a high proton concentration is lowered at the initial time. So the objective of this study was study the effect of the control addition of the acid and the reducing agent on the selectivity and the metal percentage extraction. So for that, we use this reactor in which we add a burette with the acid solution, and also we introduce a pH meter to fix the pH. So the experiment was carried out with a pH constant, and the acid was added to the system control level. And also we add another burette with the solution for the hydrogen peroxide. And for that, we studied the effect of the acid feeding. Also, we studied the effect of the initial hydrogen peroxide, the effect of the initial pH, and also the effect of the double addition. But here, I don't have too much time to show all the results, so only I'm going to show the first one. So here, comparing the batch and the semi-batch results, we have 3 experiments, both in 2 in batch reactor and 1 in a semi-batch reactor. Here, there is 2 graphs with the metal percentage extracted, the lithium and the cobalt, and we can observe that for the same initial condition, the semi-batch reactor obtain like higher metal extracted percentage. But the most interesting is here in the cobalt-lithium ratio, because we can observe that the selectivity is enhanced in the semi-batch reactor. But here maybe we can observe even better the advantages of the semi-batch reactor. In this graph, it's represented in the bar the reactant consumption, the green one, the acid, the blue one, the hydrogen peroxide, and with the point represent the metal extracted. So here, if we compare the batch with the simple semi-batch reactor, we can observe that almost for the same amount of the reagent, the percentage of lithium and cobalt extracted is almost the double. So one of the advantages is the optimization in the use of the reactant. So the conclusion of this study was that, of course, the hypothesis was confirmed. Maintaining the low proton and high hydrogen peroxide concentration enhanced the selectivity. The semi-batch leaching system improves metal extraction from lithium-ion battery cathode compared to the batch system due to the possibility of operating at low acid concentration. And finally, the semi-batch reactor optimized not only the percentage of metal extracted, but also promote a more effective use of the reactants. And I don't want to finish my presentation without introducing my research team, and the leader is the Professor Rodriguez Maroto. And this is all. Thank you so much for your attention.
Thank you for your presentation. It's the time for question. I have one question. Is it possible to use your method in industrial scale? My question is concerning about the economy of this process, potential economy of this process.
It's a good question. It's true that these experiments were carried out in a lab scale, so now we need to expand our experimental setup, and now we are working with a pilot scale, but because we need to also study the hydrodynamic of the reactor, but we believe that it could be possible to implement this method in the real industrial process, because the reactor will be the same. Only you need to take account that the volume that you add to the system. So maybe if the reactor is 1,000 liters, you need to load only 600 liters, because then during the process you are going to feed more volume. So, but I think it could be possible to implement in the industrial process.
Thank you very much.
Thank you.
The end of this session, we were talking about the photovoltaics, energy transition. Photovoltaic is a part of energy transition. Also, biogas and energy storage is the part of transition, and also about the heating, because energy transition is not only electricity but also the heating. It's now the time for coffee break, and I would like to make a together picture with all presenters in this session. Thank you very much.
Welcome to the closing session of the 5th edition of the Green Deal Conference, Strategies toward Green Deal Implementation, Water, Raw Materials and Energy in the Green Transformation. I can see that our prelegents from our last sessions are already ready to present the 3 very important aspects of the Green Deal transformation. First, dedicated to the low perspective of the implementation of the directives that are correlated with the green transformation in the water sector. That will be presented by Professor Małgorzata Cimochowicz-Rybicka from Krakow University of Technology. Then we will proceed to the second very important topic that was underlined during this conference, social corporate responsibility in the green transformation, that will be presented by Dr. Monika Sade from Krakow University of Economics. And then we will proceed to the topic that I think hasn't been even one time presented during the Green Deal conference, but it is very important topic dedicated to the gender aspects in the environmental science, and I'm very happy to welcome Professor Zofia Łapniewska from Jagiellonian University in Krakow. And now I would like to give the floor to the first presenter, Professor Małgorzata Cimochowicz-Rybicka from Krakow University of Technology.
Thank you very much for introduction. And first of all, thank you very much for invitation for this perfectly prepared conference, because I couldn't say it before, so I have now occasion. Yes, my presentation is so-called light presentation, because there is no any scientific research, but about some institution which is very strictly connected with our university because of the 2 doctorates, implementation doctorates, which are conducted at our university. So one of them is a PhD thesis concerns wastewater treatment and sludge disposal. Second one deals with water contamination with a special emphasis endocrine compounds. So co-authors Monika Ochmańska, it's a doctoral school of our university, and Tadeusz Bochnia, one of the directors of this company. In fact, I am not employed in Kraków Water, but as I said before, there are some very closely related to our common investigation. So, very short plan, Kraków Water history, legislation, some changes, directive supplier obligations, Kraków Water, it's here, yes. Kraków Water activities towards implementation of these assumptions. So the history of this water company, it was presented yesterday during this presentation of my PhD student, Monika Ochmańska. So just now I would like to say very briefly from 13th century, starting from the artificial channels in Dominican monastery up to early 20th century. Then water from the Vistula River was taken, and it was 1901 probably, and municipal water and sewage company in Kraków was established. So we have now in Kraków 4 water treatment plants from Rudawa River, Dłubnia River, Raba River, so it's a very big retention reservoir in Dobczyce, and Sanka River near Bielany place. So from 2021, Kraków Water was established, and it's called and its official name now this entities. So the scope of activity of Kraków Water is collection, treatment and supply of water, disposal and treatment of sewage, and also construction and water and sewage, heating, gas and air conditioner, even in installation, of course. So the main clients, the first group are recipients of collective water supply and collective sewage disposal, and there are some private individuals and commercial law entities and some institutions as well. And the second group of main clients, wholesale recipients of services, so our surrounding communes. And certificates held in Kraków Water. So in this context of directive, it's very important. Service of Standards, ISO, and certificate accreditation of the central laboratory. Some few words about this laboratory I will say a little bit later. So legislation. We know a directive and, of course, assumption of this legislation. Unfortunately, up to now, we have no transposition to our Polish law. And it's act amending the Act on Collective Water Supply and collective wastewater disposal, and certain other acts are used now. It's established from 2070s, and we hope that in the first quarter of 2025 we'll expect some other documents. And the next step, it will be regulation of Minister of Health on quality of water as an executive kind of the act. So the main goal of the water supplier, it's in context, of course, this directive, is providing drinking water to the point of compliance. So it's here and compliance point, this very short definition, what does it mean exactly? A point at which water must meet the requirements in accordance with the regulation of the Minister of Health originated from 2070s. So it includes also designates water collection points and set a schedule, performs research, raw water, of course with respect some parameters around this watch list of directive, drinking water, including compliance monitoring, extending test, monitoring of radioactive substances, parameters from the waste watch list, operation monitoring, especially turbidity and collifages. And the next step indicates the laboratory to carry off this text of water sampling for testing the quality of drinking water, submits to appropriate district sanitary and epidemiological station in Kraków. With some days, of course, which are indicated in the regulation, in accordance with the regulation. So it means that there are some test reports with respect to compliance monitoring, information on exceedances, compliance to the monitoring as well, and information on exceedances according to the watch list. So there are new appeared substances which should be analyzed in this test and this procedure of this water companies. So this bisphenol A, chlorides, and microcystin, per, and polyfluoroalkyl substances in sum and as a total as one. So uranium in addition. And some activities which allows to this company achieve some assumptions of this directive. So first of all, some projects which are realized, implemented in this company. The Research and Development Center for the Kraków Water. So it is a very large laboratory, very well equipped. And implementation, so it was creation of the Water Supply Research and Development Center, City of Kraków, and it was by purchase of highly specialized research equipment, development and implementation of analytical methods, launch of routine monitoring of this microbiological and chemical water quality indicators. So, in the result of this one, in Kraków, and the company of Kraków Water is one of the best laboratories in Poland, so we can say is one of the top national laboratories. Kraków, some words maybe additional about the central laboratory implements to the assumptions. So additional parameters which have been, as I said before, should be listed as well from the group of emerging contaminants and pharmaceuticals, endocrine compounds, and microplastics. And the research stage has started. What does it mean? So it means that this implementation doctorates started 1 year ago, and it was with a special with emphasis of the removal of endocrine compounds from water. So it is it will be implemented and some special pilot scale installation, and I will say about it for a minute, but this installation is a result in this the next project, innovative technology for the treatment of saline surface water in circular economy, so NCBR project in implementation 2021 to 2023. And construction of this installation is just, so place of this construction is just at the water treatment plant, Bielany water treatment plant. So it looks like more or less. So there it is, of course, a whole one and contain kind of installation. Innovative technological solutions for the removal of selective micropollutants. So it concerns just me and maybe not exactly me, but my PhD student. But it also be probably will be carried on some investigations on how it was very special one, some kind electrolysis, so it is very important as well. So because some processes which are included in this construction, it's starting from coagulation, and it's a sedimentation with multi-stream settlers. And, okay, but I'm looking at the time here. Settlers, and then are filtrations, and ultrafiltration and reverse osmosis. So I think it's a quite nice base for removing such reacting compounds, microcompounds from the water. Okay, and the next project from this water company, it was modernization of water treatment and distribution infrastructure. So not only a laboratory point of view, but this infrastructure as well. So you know here it's some mention so scope of this, more on this is disinfection Dłubnia, ultrawaves, modernization of Raba, second step of rapid filtration, modernization at the Rudawa water treatment plant, comprehensive modernization, so it network, and renovation and replacement of asbestos cement pipes. And task number 4 is just completed. Exactly, it was completed in 2023. Others prepared in 2023 by preparing documentation. Okay, and before this directive assumptions occurs, Kraków Water started to organize the special task force for water safety plans. So scope, development and implementation of preventive risk management. It is a very important point with these directions, assumptions as well in Kraków Water, of course. There are some activities, issues implemented in 2023, current risk assessment, coordination of activities between Kraków Water and provincial and district sanitary and epidemiological station in Kraków. Updating the document entitled Water Safety Plan, it was completed as well. Organization with State District Sanitary Inspector in Kraków of 2 conferences, and examination of a draft act, amending the act on collective water supply and the collective sewage disposal. So, besides this project, there are a lot of training, conferences, lectures conducted by Kraków Water. Auditory, water supply companies, municipal governments, sanitary and epidemiological stations, industry organizers. So based on these experiments, based on this project, based on its experiences, we can say that this Kraków Water company has a specialized laboratory equipment, trained and competent staff, implemented testing methods for required parameters, water monitoring in Kraków, water supply network monitoring, water supply network modernization, and preparation of water safety plan. Thank you very much.
Thank you very much, Professor Cimochowicz-Rybicka, for this very nice presentation regarding the different activities that are taken by one of the biggest wastewater treatment plants, but sorry, Water Kraków, yes? Water Kraków Utility, this is the correct name. Kraków Water Utility, yeah, okay. Yeah, but this is one of the biggest industrial plant in Poland and very important to be a part of this green transition. I like very much this education pathway of our company. Thank you very much, and now we'll proceed to the next prelegent with a very important topic dedicated to the social corporate responsibility. Dr. Monika Sady from Kraków University of Economics.
Good afternoon, ladies and gentlemen. Thank you, Professor Small, for inviting me today. I will try to discuss the importance of ESG for green transformation in 15 minutes, but that's mission impossible if you're in the topic, but I'll do my best, hopefully. As you know, ESG derived from corporate social responsibility, which was more of an ethical engagement of companies in social and natural environment. And it incorporated into ESG, which is strongly connected to legal regulations. Right now we are talking about ESG 2.0, which is actually the new ESG deriving from intentional activities that companies want to undertake, not they're forced to. So traditional CSR, as I said, was more connected to ethical issues. With ESG, we've got environmental, social, and governance issues, which are integrated into the core of corporate strategy. And through ESG, we can talk about promoting green transformation in a measured and strategic and sustainable way. So environmental impact, environmental issues impact corporate strategies, operations, and long-term goals. They can be connected with both challenges and opportunities for companies. And here we're talking about aligning to legal regulations or customer expectations, or aligning to United Nations Social Development Goals. The continuous deterioration of environment requires us to take specific steps. We're doing energy saving, emissions reduction, low carbon economy, green industry, which are the new trends for the global economy and the drivers for the green transformation. Within the environmental issues, we have three factors that at most, they influence what happens in the companies and what are their strategic decisions. So within those environmental factors, I only show here the most important ones and the most general ones. We have these pollution and waste, we have natural resource scarcity, and we have climate change. Within the pollution and waste, companies that create a lot of pollution and waste, they're highly sensitive to reputational risks. This can cause them a lot of harm, which is influenced by the customer and general stakeholder expectations towards the companies to produce less waste and to be smaller pollutants. Because of that, they start investing in R&D because they want to innovate, to produce less waste and to pollute less. Of course, the pollution and waste also influence health factors, both of employees working in production lines, but also at end product customers, which also can cause huge reputational damages to the companies. And that all requires a lot of money, because if we want to invest in cleaner technologies, we need to invest. We need to put some money on the table. Natural resource scarcity is strictly connected to labor and to labor migration due to economic issues, due to health issues. Water, minerals, energy, their prices grow every year, which is strictly connected to increased cost of inputs, of course. Shortages and delays in supply chains can greatly affect company operations. Reputational risks deriving from over-extraction of minerals and over-usage of natural resources can be a huge damage. Companies try to compete, they try to innovate in who takes the least advantage of the natural environment. Of course, this also impacts global expansion of companies, because companies will be moving their operations to regions or countries which provide them natural resources. And of course, over-extraction of natural resources causes long-term sustainability concerns. And the last factor is climate change, and this physically can affect what happens in the company. Floods, extensive heats, tsunamis, and all the natural risks that we have, they can physically impact company infrastructure and assets and harm the operations. Because of the climate change, regulatory issues, they change every year. We know that more and more regulations is coming on the environment, so companies need to be in line with that, and they need to keep up the pace in order to be able to operate. And of course, we're talking here about stranded assets and financial risks. So what can companies do to manage those risks effectively? There are numerous ways. I've put just some of them on the slide just to show you the broad picture. So they can conduct climate risk assessments to find vulnerabilities in their operations and in their strategy. They can monitor and report, and ESG helps greatly in that, because ESG are specific metrics that help to measure and report, especially environmental progress. They can set sustainability goals which help to align their business strategy to sustainability. They can adopt ESG frameworks to align their operations to those sustainable standards. They can invest in resilience. So they can innovate and try to find more resilient infrastructure, or they can try to diversify their supply chains to have better chances of finding the resources that they need. They can innovate, they can implement green technologies, they can implement circular economy principles. As we've heard on Wednesday, there are not only 4 or 6, 8, or maybe even 11 now. So thank you for the Wednesday update about the 11 R's. They try to find resource efficiency, so they're going to innovate and create new technologies that will use less resources. They will seek sustainability certificates to prove their intentions and their operations. They will diversify supply chains to be more flexible. They will collaborate with governments, NGOs, other companies, or engage their stakeholders like competitors, customers, decision makers, to join them in that journey, because the bigger the network, the bigger the flexibility. So what is the relationship between ESG metrics and corporate sustainability goals? When we're talking about defining objectives, we are talking about setting corporate goals. When we are talking about measuring progress, we are talking about ESG. In terms of specific, standardized measuring framework that can help companies measure their performance in the social, environmental, and government aspects. Strategy development helps, ESG helps companies to identify gaps in their practices and create a better strategy. The ESG helps companies to measure, report, and elaborate on their process, and helps the transparency, because the more transparent companies are about their activities, the bigger the value of their brand and the bigger the trust in the brand. Of course, if we have many different stakeholders, aligning their expectations and aligning them to the ESG strategy is crucial to create the long-term value. And of course, regulatory and benchmarking compliance. So ESG framework is strongly influenced by UN 17 Sustainability Development Goals and Global Reporting Initiative principles. So we have this good framework for measuring sustainability. So what's the role of stakeholders in this transformation? We are talking both about internal stakeholders like customers, employees and owners, and external stakeholders like customers, competitors, investors, governments, etc. So if we look at those groups of stakeholders, each one of them has different interests. And for companies, it is very tricky to manage those complex interests of those stakeholders to create one strategy that would suit all. So engaging those stakeholders, collaborating with them, will help companies to create this more unified and better suited strategy that would build trust and actual change in the natural environment. The better the quality of the relationships with the stakeholders, the better crisis management and opportunities management for the companies. And of course, better crisis response and business continuity planning. So what are the good and the bad sides of ESG in green transformation? First of all, the biggest strength of ESG is that it's a catalyst of green innovation. There are specific expectations towards company about their environment activities, about their environmental practices. So companies are forced to rethink their technologies, rethink their operations. The second thing is that stakeholders, external stakeholders, have certain expectations, and the government and the all regulatory bodies have their expectations as well. So ESG helps companies to align to those expectations. But of course, it also has a bad side. There is a big risk of greenwashing. We have greenwashing when we have this exaggerated or falsified environment claims by the companies. And they are trying to look as best as possible in the reports, in the ratings. So this might create this field for over-exaggerating. Another thing is the challenge between aligning short-term financial goals with long-term environmental goals. So when we're talking about investors, when you invest in a company, you want to have return of investment as soon as possible. So if you invest, you want your money back quickly. And you're not looking into a longer perspective, just like we are looking when we are talking about environmental claims. So aligning this long-term value creation mindset with our cooperation with stakeholders should help a bit to align those challenges. And of course, navigating hurdles is super difficult for companies in all industries, but strong leadership will help to engrave ESG into corporate DNA. Because if we have that, we have corporate culture that evolves around sustainability, and that will change the mindset of the company and the stakeholders. And this will be followed by the cooperation with governments, NGOs, other companies. This will help to be more clear, transparent about the company's operations and the metrics, and will build trust and stakeholder engagement. So I think the key is for companies not to be closed and keep all the information to themselves and maybe nobody will notice, but to create this network of cooperation, because then they will be more resilient to everything that's happening in terms of legislation and environmental changes. Thank you very much. I made it in 12.5 minutes.
Thank you very much for being so perfect in time, even before the time. And thank you for underlining this necessity of the collaboration, because we, as the researchers, we really want to collaborate with the industrial parties as well. And it's very important because basically, I think that most of the results that have been presented during this conference, that's the results that someone will need, and that's the companies. So this is very important. Thank you very much. And now I would like to proceed with a very important topic that is more and more important in any sciences. But this time we would like to underline the topic in the environmental sciences dedicated to the gender aspects. Really very important, because if we would like to participate in any Horizon project, we have to have the plan for the gender elements in our institutions. And I think that European Commission now, when they were setting the new group dedicated to the gender aspects, they would expect more than only gender plan in our institutions. And now I would like to invite Professor Zofia Łapniewska from Jagiellonian University in Krakow for presenting this important topic.
Thank you very much to be the last person in the closing panel. It's my privilege. So I'm a feminist economist and ecological economist. So to prepare the gender importance in environmental science lecture. It's the first time I do it in environmental sciences, but as Marzena already introduced me, yes, so yes, we have the gender requirements also in the Horizon topics, but since Poland joined the European Union, yes, in most of the programs and projects we need this gender minimum and gender balance. So I'm very happy that more and more this is present also in our research. So to start with it, first I have a quiz to you. These are very important 3 women. So my question is, do you include these 3 women in your teaching courses? Because they are very important women in terms of environmental sciences. So the first one on the left is Eunice Newton-Foote. So yes, she was related to Isaac Newton. She was American suffragist, and she was the first one to develop and to observe the greenhouse effect. So she observed 3 cylinders, one with carbon dioxide, one with wet air, and one with the nitrogen oxide. And then she observed that when they're exposed to the sun, this one with carbon dioxide warms up very fast in comparison with other cylinders. So she was the first. Look, like she published her paper in 1856, so it was before John Tyndall observed this effect, like 3 years later in Ireland. So, and she was not really famous until maybe 10 years ago, because someone discovered, oh, she was before John Tyndall. So yes, so she's the mother of greenhouse effect. Maybe it's not so good to be the mother of greenhouse effect still. Yes, she was a great person. Of course, she was a feminist at the time. So yes, so she's still important in our research. The second one is the Rachel Carson. So she was a biologist, also American one. And she was the precursor in a sense that she observed that in the beginning of the century, very often the pesticides were used in the US to kill insects. And of course, the book is about Silent Spring. So in the food chain, when you have no insects, you have no birds. So this was so influential that most of the ecological economists, they are really citing her book and as a main inspiration. So after her, like more models were developed in a sense of balancing or sustainability, yes, in between this social, ecological, and economy. And the third one, maybe more of you are aware of, this was the first report, The Limit to Growth, published by the Group of Rome, and the limits of growth. So she also contributed to ecological economics, but she was the one who developed the computer program called Word3. It's not the third word, but Word3. And she made the simulations how this condensed CO2 emissions and other impact on the environment would also influence the planet. So, and also like population and some other factors. So this book was so influential that afterwards the Brundtland Commission was set up, and all other, Brundtland, also the women, yes, Graham Brundtland, the Norwegian Prime Minister, that she was a head of this commission. So when you think of environmental sciences, really, so women had a great impact on the science itself and what they developed, yes, and very often they're omitted and they're not included in the modern curricula. So when you think about this androcentrism in environmental sciences, I'm very happy that here at this conference we had so many women and women's speeches, although the energy panel was dominated by men. Yes, there was only one speaker sitting over there. And yes, but what is this androcentrism? What is this masculine perspective, we can say, in environmental science? So first, how we select the university staff, yes? How many women are among lecturers? So nowadays the question is, how many women professors are among lecturers, yes? Because of course, the early career researchers, scientists, there are many women that we have, and then they drop out. They don't do careers in research and environmental science, so it's really a pity. Then the second, where the funding goes, yes? So this is also the question of the Horizon and other projects, yes? So who receives the scholarships, yes? Who receives the grants and for which projects, yes? Are there also any qualitative projects or only quantitative, yes? And what does it mean really that this gender perspective in environmental science? The design of curricula that I mentioned, yes, are these women included in the curriculum, in the courses, and also like what research is included, and do women have equal chances to be in the textbooks or handbooks to environmental science? And of course, when you go to the government strategies and research, then, of course, we also observe that there is a omission of role of women in these strategies, like political strategies in terms of environment. And finally, the perception of environmental science as an objective discipline is the same with economics. No? Economics is social science, but always we think, oh, it's objective because we measure environment, yes, but it's not, yes, because this is not only about mathematical models, yes, this is about the fact that people have relationships with other humans, with environment, and because we are gendered, we have our experiences. Also, this is not only gender, yes, it's also race, the experience of migration, yes, sexuality, a lot of things that also they affect the way we think and we perceive our environment as such. Yeah, so do we act rationally? Of course not. Yes, we are only human beings. So then, often we don't have the full information, we make mistakes, we act under pressure from politicians, from authorities, yes, from business as well, yes, results, and then a lot of things are taken like aside. And the attitude of women and men to the phenomena studied may be different, yes, we have to acknowledge this. And yes, when we think about what is gender in environmental sciences, we have to ask what is gender per se. Yeah? So of course this gender definition comes from the 60s, from the second wave of feminism in the US. So the research started on expectations regarding social roles of women and men. And that's why there were not so many women in the academia in the beginning of the century. So now we use the definition, I use the definition that this is a social construction of identity, assigning different roles, rights, and opportunities to people, depending on their sex, yeah, so the biological sex. So what we can recommend from the feminist perspective, of course, ecofeminism has also this black book, let's say, every science has a black book and gold book, so. But when we think from the social scientific perspective with critical post-structural positions and the feminist political ecology position, so the gender is a critical social variable in securing access and control of natural resources. Yeah? So we have to ask ourselves, who has the access to resources, who owns the resources, and also what is our relationship with these resources. Yeah? So there's interacting moments, and of these moments we see that inequalities such as race, caste, class, they shape this environmental change. Yeah? So also what we do with the environment also depends who is responsible, who has the access, and who has influence on the change of environment. And environmental knowledge, as we produce knowledge, as scientists, we produce knowledge. So this is also shaped by our social, political, economic contexts. And the contexts themselves are gendered. All this context, yes? It's different contexts when we speak to women. And right now I speak like to half, let's say, yes. But there are different contexts where you can say something about the gender research and, yes, and how it will be perceived. So what is the proposal? So first, we have to think, even when we do the environmental sciences, even the research on waters, we have to think, okay, what are the power relationships in our research? Yes, who has the power? From the context, right now and here and now, but also from historical perspective, who used to live there, how they were managed, the ground, the soil, the water, air, and so on. There is no value neutrality. This is a myth. Yeah? So it's not possible and it's not desirable, so we can use this normative approach. This is like emphasize relationality, should be emphasized between human and human environmental interactions. And we have to focus also on what's changing over time, how it's changing, what interactions are there, if there are shapes by patterns of oppression, such as stone color, racial, ethnic, class, caste, and other lines. We have to think about diversity, yes, and intersectionality in a sense of intersections of different oppressions. And we have to think about the dialogic character, yes, if we want to change, so also how this change would be perceived by different genders, by this society in this particular context. And always we have to think in this power relationships context. So also in terms of methods, we have to think locally, Yeah, so of course, if we do the water project even in Krakow and maybe in, I don't know, Dubai, yes, or some completely other city like, I don't know, Shanghai, it's also different context. Yes, this reflexivity is important. So we have also this gendered environment and histories, and this situated knowledge of people living in that place and their understanding is very important. We have to think about dialogue and relationality, how to do relations, establish relations with our topic. We have to be critical, we have to interrogate if we want to change, and also we want to use the multiply methods and triangulation. I think it's now very popular, yeah? So qualitative research, quantitative research, literature research, we have to combine different sources and we have to be open to these different approaches, so not only qualitative research. Okay, and my last slide, I think these are also two women. I enjoy this slide to show to students from ecological economics because I think I have a fantasy that economics is a culinary experience, yes, so from cake to donut. Yes, but yes, the first chart is developed by Hazel Henderson. She developed this picture, she drew this picture in 1982, and she showed that the private sector, the business that we always talk about, it's just a layer cake with, like, this is just an icing on the cake, yes? And to this sector to prosper, we need public sector, we need our shadow economy, which is unpaid jobs that we do every day. We need love economy, that we contribute to the economy also and we care for others, but also it all sits on Mother Nature, and Mother Nature is also exploited and so on. So of course you can see it's very simplified, but you see that the business is only this icing and the rest is so necessary to be built, really, that also the private sector can prosper. The other graph I think you're aware of, it's from Kate Raworth, so she's a British economist. So she observed that, of course, we have to think about our ecological ceiling, yes, so we have the some boundaries, planetary boundaries, and this is developed by the group from Stockholm. So they see that we have climate change, ocean acidification, chemical pollution, nitrogen, phosphorus loading, freshwater withdrawals, land conversion, it means from forests to fields, for example, biodiversity loss, air pollution, and ozone layer depletion. So we have to think about these boundaries, but at the same time, we want the social foundation, yes? We want people to have fresh water, food, to be healthy, educated, to have some income, to live in the peace conditions, have political voice, social equality, gender equality, housing networks, and energy, yes? So how to live within limits, but also to build the social foundations for the entire society. So we just have this donut in the middle. Yes, it's not easy, but always when you work on water, yes, itself, so it's only water, but then you have all these other boundaries also you have to think of. They're all connected, yes, together. When you think about energy, it's also air pollution, it's acidification of oceans, everything. So, yeah, so this big picture also, so women are there also developing nice pictures, and yes, and we have to think about this interrelationships in our science and if in whatever we do. Thank you very much.
Thank you very much, Professor Łapniewska, for this great presentation. I think that the topic of the gender in the environmental science and if in any sciences will be developing very fast in the coming years. So we hope so as well. So thank you very much. Now I would like to close the session dedicated to our excellent prelegents that were women. We recognize this one as well. So I have to say that I'm working for the women in science, so I support, of course, women. However, it was not my idea to have only the girls. However, in the first plenary sessions, we had 2 times more men. So I think we are sometime in the middle. So thank you very much. Now I will proceed to the last few informations that I have for our participants during this conference. So first one is dedicated to the announcing the awards for each session. The moderator of the session was selecting the best presentation with the support of the commission that was also included in this session. So the session, the Green Deal and the Recovery of Biogenic Raw Materials, that's the Regina Kalpokaite from Lithuania. Session Waste, Wastewater and Innovation, Sophie from Italy. Session Implementing the Green Deal Strategy in the Water and Wastewater Sector, Sophie from Cyprus. Session Green Transition in the Energy Sector, Marco from Italy. Session Trend Supporting the Implementation of the Green Deal, Beradi from Morocco. Session Sustainable Management of Raw Materials and Waste, Roberta from Italy. That is the online session. Awards. The session Water Recycling and Supporting Technologies, Dominika from Poland. Session Minimizing Carbon Footprint and Innovation in the Energy Sector, Aistis from Kaunas from Lithuania. Session Minimizing Carbon Footprint and Innovation in Energy Sector, again, Eva from Wrocław from Poland. And in poster session in English, Leonid from Ukraine, and in Polish, Anna from Poland, in Polish, of course. That's the online sessions. And now we are proceeding to on-site sessions because we had the opportunity to hear them here on site. Water, raw materials, energy in the Green Deal session, Grzegorz Pasternak from Warsaw from Poland. Session Challenges in Achieving the Goal of the Environmental Free from Toxic Substances, Dominika from Kraków, Poland. Session Implementing the Green Deal Strategy in the Water and Wastewater Sector, Agnieszka from Kraków from Poland. Session Climate Action and Circular Economy, Tomasz from Białystok from Poland. And session Monitoring the Implementation of the Circular Economy in the Water and Wastewater Sector, Monika from Kraków from Poland. And poster session in English, Maciej from Poznań from Poland. There is second award for Weronika from Silesia in Poland, and session Sustainable Management of Raw Materials, Łukasz from Silesian University in Poland, and the last session Sustainable Management of Energy Resources, Grzegorz from Gliwice in Poland as well. Regarding the guidelines, of course, the best oral and poster presentations, we wanted to give this kind of the achievement for the best presenters in both on-site sessions, online sessions, poster sessions, oral sessions. So we hope that it will be a good motivation, especially for the young researchers, because we know that we are collecting this kind of the achievements, and they are quite important for the students and PhD students, but also for the young researchers. Certificate of the presentations will be sent to the presenters, only presenters who were on the on-site and online sessions via email, and all the conference, including the online and on-site sessions, have been recorded, and they will be available on our YouTube channel. So even now, we have some information that we are still, online. You are very welcome to publish the papers that are supported, are support for our conference. All abstracts regarding the presentations that have been presented, this is very important element of our strategy and regulation in our conference, will be published in the conference proceedings that will be published in the December 2024 online. You are also welcome to submit the papers to 3 special issues in the sustainability, desalination and water treatment, Elsevier Journal, and water policy supported by the International Water Association. I have to mention our organizers, and partners and patronage. So the Division of Biogenic Raw Materials in the Mineral and Energy Economy Research Institute of the Polish Academy of Sciences is the main organizer of this conference. This is our 5th edition, first one on-site and online, and I can say that in 2026 we will have the 6th edition that will be also hybrid version, that's mean online and on-site in Krakow. Conference partners, that's Proman Consulting company from Vienna, European Water Association, Fundacja Optimus, Gdańsk Water Foundation, Greenback Company, and Trener Nauki. We've received the patronage from Ministry of Science and Higher Education, Ministry of Climate and Environment in Poland, from Chamber of Commerce, Polish Water Works, National Center for Science and Education and Development, Polish Young Academy, and Desalination Directory Outline and European Desalination Society, and Forum Exploatatora Journal, Polish Journal. What I have to say, that's very important information, that our conference would be not possible without the finance support from the Ministry of Science and Higher Education. Each year we receive the support from the Excellent Science, support for the scientific conferences, so we are very happy that each of the time when we applied for this program we were successful, and first one in the hybrid sessions, with the hybrid sessions, and we have been also approved. So we are very happy, and the next edition we already signed a contract with our ministry, so we are very happy to welcome you in Krakow in 2026. Scientific committee, you can check on our webpage. There's a lot of great professors, doctors, and other people who are supporting the conference. And this year we received so many abstracts and people who wanted to join our conference, so it could be not possible without the support of the even checking the abstracts and giving some advices how to improve them. So thank you very much for everyone who has been involved in this scientific committee, and of course each member is also included on our webpage. Organizing committee, I was thinking about this slide and I don't really like it because I shouldn't be in at the head of the division. It's a slide from our general presentation of the division in our institute. However, the most important people are there, and I would like to say big thank you for my team. For sure, without people from my team, it will be not possible to be here today. That's, I'm sure, 100%, and especially thanks for Dominika Szołdrowska, that you have been in contact with Dominika mainly, for Magdalena Andrunik, Paulina Marcinek, Edyta Waluś, Mateusz Skalny. They are there, but you should be here, I think, with us. And really many, many thanks for you. And yeah, we have also the technical support with the company Aspecto. And Aspecto I also wanted to mention because they support us in each kind of the event that we are organizing, and we are collaborating quite well, I have to say, because without saying the words, we are doing our jobs, and that's very nice. So thank you very much for Grzegorz and all the team from Aspecto. Thank you very much for participants that have been joining. Yes, I think give ovation to you, that have been joining our sessions on-site and online. I think that it's something like 2 conferences that we have organized now. But of course, without the participants, there will be not conference. But we recognize also that the topic of the green transformation is more and more important for different scientists. That's the economy scientists, the humanities scientists, also social scientists. In general, we are the engineers. However, we are very open to also collaborate with other our other disciplines, because it's very important, like Monica mentioned, the companies also have to collaborate with us, so we are very open for it. And so thanks for participants for being a part of this conference. And that's all from my side. Thank you for you being here, and see you in 2026.